Okay, kids, and we're back. Chapter 6 is where we're going, which, in my opinion, really should be in Unit 3 with Chapter 7 and 8. I don't know why they did that, makes no sense to me, but that's my opinion. And we're going to talk about something you've really seen before, but we want to make sure it's in our minds here, and that's gravitational fields. And I want you to remember that because matter has a property called mass attracts other mass. So recall, mass has attraction for mass. How is that shown? How is that manifested? Well, it's manifested through something you've already seen. G, vector, called the gravitational field. And all around any object really, but most obviously seen with large objects like stars, suns, planets, moons, things like that, galaxies. You have where the mass resides. But outside of the mass, beyond the physical limits of the mass, is the field. In this case, the gravitational field. And the field is stronger closer to the object. I'm going to remind you of the equation. The strength of this field caused by the mass here is equal to G, the universal gravitational constant. What's up, big G? The mass of that object, how much stuff is there, divided by how far you are from the center of that object squared. So even though you are way out here, let's say this is a sun, a star, and this is a planet here, even though you're way far away, you're going to feel the effects of the presence of this mass here through a gravitational field having an effect on the mass here. What is the effect of a gravitational field upon another mass? Well, that would be a gravitational force. F big G, where now we need to put in the mass of the object which is experiencing the gravitational field. And we would call that a test mass. We're saying, hey, is there a gravitational field here? Well, let's put a mass here and see if it feels a force. You could do the same thing here. Is there a gravitational field here? Well, let's put a mass here. Let's see if we experience a force. Right? Now, this field that we're talking about right here is variable. It changes. It depends on how far away you are from the center of the object that is causing the gravitational field due to its mass. We've run into other gravitational fields, like this one. G is negative 9.8 newtons per kilogram. It's constant, and that's where you are near the surface of the Earth. All right, that's a constant field. So you have experienced this before. You've also experienced dealing with gravitational fields when we've dealt with uniform circular motion. The only way we're going to have something in orbit is if the mass that is in orbit is experiencing a gravitational force which is caused by a gravitational field. That's the only way this is going to happen. So you've seen this before, and we've done equations. We've solved things like, let's find out how fast this object is moving if it's in a stable orbit. So we went F net equals ma. We realized that the force of universal gravitation is the only force acting on little m, right? And we realized that that acceleration is definitely centripetal. And then we equate the two equations and we find how fast the object has to be moving so that it is in a constant, stable orbit. So we're starting on 6.1 today, a little bit of review. That's okay, no problem. And we'll see you guys tomorrow. Bye bye.